Welcome back to a series of lecture on digital image processing. So in this class, we are going to discuss about the supervised classification. So as I said that any satellite data in the form of digital needs an analytical procedure to classify the different object or the features present on the surface of the earth. When digital image processing came into picture, that they have divided the various analytical procedures, and slowly in the evolution of computer, slowly in the evolution of processing system, that they have got number of analytical procedures. But initially they went to classify by using the digital number into various classes. As far as the digital image processing is concerned, supervised classification or classification system or unsupervised classification system is the beginning of digital image processing. They initially started doing an exercise with the classifying, the grouping the digital numbers into a set of classes, different classes. That is the unsupervised classification. So if you classify the analytical procedure as a basic or advanced or simple, this comes to be a very famous classification. Still, many of them are working with supervised classification to classify the satellite images, to discriminate or to demarcate the different features. So, keeping in the context of the importance of this analytical procedure, that because it is being mostly used by the remote sensing scientists, I am going to discuss about the important issues related to this, how supervised classification works on digital image processing. And the meaning carries by the title itself, supervised. It means we are going to supervise the computer, or we are going to see how computer is classifying. So it means I am going to give a training to my system that take this colors and group these colors. It means that supervisor is involved. Supervisor, it means human intervention. Human intervention is more in supervised classification. It's like on and off problem, like that you must always interact with your system and then says that this is one class, this is second class, this is third class, like that. So in unsupervised human intervention, as we have already discussed in the image classification, it is less when compared to supervised classification. There also we have to operate, we have to go to menu bar and then select unsupervised and give input file. So intervention with respect to the analytical procedure, you can classify with 10, 20 or 30 in unsupervised, but here you have to individually select the pixel. Say to your computer, this is the pixel of vegetation. Says the computer that this 4 is the reflectance of turbid water, 0 is the reflectance of black body water absorption. Like that we have to train our system. We will see how it works. Supervised classification uses image pixels. Image pixels, it means numbers representing the regions of known. That's what I said. You see, you have many classes, but normally you classify your objects into various groups, like maybe a water category, maybe a sand distribution, maybe a water forest category, maybe urban category, maybe a corn category, maybe hay category. You take whatever the features on the surface of the earth, take the data and give the training to your system and see the output. This is how classification is being done. So this is one, you are giving your training stage, the second you are grouping, and then third stage accuracy. After looking that accuracy also we have to assess. So stage 1 is giving training, stage 2 is classification. Normally we give wherever we feel homogeneity, so that we will group such classes by giving training and to classify the unknown pixels. This is very famous analytical procedure, so it has a lot of attraction to the remote sensing people, those who are working with the satellite data. We assume that the spectral response of the feature is relatively consistent throughout the image. We feel, suppose if I am classifying agriculture land as 63 pixel value, I assume that my total image of my study area, so maybe the 63 to 65 is the agriculture land. I must have an idea of my field. That's what I said. Normally, I used to tell remote sensing technology will reduce your work. I mean, field work. You cannot say field work is no stopped. But I advise as a geologist that we have to do a lot of field work, even though if the system helps you to demarcate, it helps you to interpret the futures very easily by sitting in the lab. But if you go to field, you will get a lot of other ideas that why that particular feature behaves differently from particular direction. Right? So many things which you can be able to predict. That normally we speak geobotanical indicator. Vegetation speaks about the resources present below the surface in terms of water, in terms of mineral, in terms of many resources present below the surface of the earth. We feel that whatever you interpret, give the training to your system that your study area will have like that. So we need an idea of our field to confirm that this is your vegetation, this is your water body, this is your sand exposure. Normally, what is the advantage? You are creating informational classes based on the knowledge of the ground, right? We are generating. That is, it means I know that this is a vegetation. Definitely, this area I have visited. This is vegetation. It means you whatever the information you have gathered and giving the information to the system to do it. I am giving training and to the systems that this is road, this is no even unusable domain also we can give training to the systems. What is the disadvantage of this supervised classification? Now sometimes it will not be same. Whatever the classes it will mismatch with others. Say for example, forest if you are grouping. The same reflectance will be there in pineapple, pine tree as well as oak tree. You cannot group this is a forest. Now, small confusions will arise. What does it mean that it is not going to stop your work? That you involve. Your intervention. You please give more attention wherever this type of confusion is coming, so that you will reduce the possibilities of error in your output. That's what I normally feel that if after 30 years we came to know that what best we can do with this technology. It is not so easy to start and say that remote sensing is very easy and a fellow who is crossing or walking through the satellite images says starting that I am a specialist. No, it's not possible. It is not good also. And homogeneity of information classes varies. Difficulty and cost of selecting training sites. Homogeneity, it is very, you cannot, sometimes these are all disadvantages. Difficulty and cost of selecting training, sometimes you cannot go to field to find, to confirm your, doubt. It is a little cost. Training areas may not encompass unique spectral classes. Yes, sometimes that is also, and those things can overcome. What are the different steps a scientist or a specialist working on this has to do? You see, he has to see the best place of display, where best combination of color is there with respect to a particular area. Mark that area as a marking site. Third, after marking, you generate multivariate statistics. Maybe you here and there you select so that what will happen? The system will take on its own minimum maximum differences. And you put, there are three methods of operation, of course. There is three classification methods: supervised class, parallel piped, minimum distance, and maximum likelihood. It's very simple. We will discuss with some examples. Colors are assigned to each class and appropriate legend, and assess the very, very important that whatever you do with the spatial, either on remote sensing or on GIS, we have to go with accuracy assessment. Otherwise, accuracy part is very important. Otherwise, we will fail in claiming that our technology proves a lot of efficiency. Modify the training set if you feel that this area is doubt. So modify the training set and ask your system to reclassify to bring the quality. So this is how it's being done. You see, you have FCC 432 band is there with RGB in composition. This is Kakinada region, and you see, now I am very confident on this area. It is no for this the whole land is the same category. I am putting it as here. After selecting giving agricultural land and barren land, and this is also I am grouping here minimum maximum will vary. Here minimum maximum will vary, and here it is a turbid water, it is a shallow water, it is a deep water. And this is a mangrove forest region. I am classifying giving the mangrove classification. After giving this type of known areas, then you can ask your system, okay, take this as a base and then do classify similar such pixel value into a same group. Yes, system will do. It will take very less time to complete the task of supervised classification. I said there are three supervised classification procedures. There are three types of supervised classification. One is parallel piped classification, second one is minimum distance to mean classification, third one is maximum likelihood. There are three methods. We will see what is the difference of these three methods, which one is that you have to employ, you cannot say that one is good, one is bad. Everything has got of its own advantage and disadvantage. You will see. And here the pixel values are compared to upper and lower limit, that is parallel piped classes, to each signature, that is minimum maximum pixel value in each band it will consider the mean of each band, maybe it will see either plus or minus 2 standard deviation, and then group. If I read you will not understand, but if I explain this you will understand. You take a band A and you take a band B, and now you see that these dots are pixel class 1. I am classifying these dots are pixel class 1, and this diamond are pixel class 2, and this again diamond, full diamond is pixel class 3, and this area I am having a doubtful and I don't know, I cannot classify. But what you have to see is the distance you will have to see. Suppose if you have here a confusion, matching of 2 and 3 is there. Sometimes you cannot say which one it comes, but you will have to see the distance, and then that is the next method. And this is row A2 mean of band A class 2. This is mean of band A class 2. This is mean of band B class 2. This A2 is mean of this one. This A2 is mean of band A class 2, mean of band B class 2. So this is how the parallel pipe classifier is classifying. But you get unclassification also, that will also group. If the pixel value lies above the low threshold value or below the high threshold value for all n band values, it is assigned to the class, nearby class. And when unknown pixel does not satisfy any of the criteria, it is assigned unsigned. This is one. It is we can visually see the two-dimensional box, but this could be extended to n dimension also. Now I am giving example. Of course, it will applicable to all. Leave them unclassified or classify them using a parametric classification. So this, after buffering, you take it out and then again you sit or go to field, bring some training sets and then do this class. This will give you also good. You see, you have a scatter plot. This is the space plot, two-dimensional space plot of band 4 and band 5. And what is you see the spectral reflectance of band 4 and band 5 for feature residential and forest area. It is there will be little confusion between these two objects, and you see you have a mixture of white and black pixels over here. Water is classified very excellently by using parallel pipe, so some confusions will come. That's what they have taken two bands and display the spectral parallel pipes. The upper you see you have a confusion in 1 and 4, because it is in the same spectral signature structure. And similarly 3 and 4, wetland and this land 3 and 4 also. This you see at band 5. At band 5, at this point it reflectance is both are same, but so confusion with this is there, confusion is with this is there. That we have to reconfirm by taking from the field database. Advantage, it is very fast, good for non-normal distribution. If you are not worrying about it, can limit classification to specific land cover. No, very tough. Sometimes it will not work. Disadvantage, classes can include pixels spectrally distinct from signature, means that means no unclassification. So that is the limitation that you cannot say that I could not be able to classify. At last you have to classify all and then group two. That's the problem with this. Coming to the second one, minimum distance classifier. It means it takes the minimum distance. No, better of explaining this, I will explain using this graph. So I have taken a field data. This is candidate pixel value. Now this candidate pixel value will see with respect to three of the object 1, object 2, object 3. What this fellow will do is this fellow will calculate the distance, and wherever the least distance is there, this fellow will move. That is the very simple. Mean value of each class it will take and then move. And you see, so classify pixels based on the spectral distance between the candidate pixel and the mean value of the each, and then it will take on its own of looking what is near to that. Advantage, fast, no, all samples or pixels are classified based on this. Does not incorporate variability of signature, that is the disadvantage. In most cases, a maximum likelihood, because it is not classifying unclassified. That's why people many times will prefer to do it this, because always nearby features will have similarity. That's why they believe that it gives very fast and good for us as to complete the work. Comparison of minimum distance and parallel pipe. So this is the parallel pipe, it is grouping and then it is giving unclassification. But here it is also grouping, and it will see the distance, and then accordingly this will take, this C will go to here. Suppose if I have here pixel value here, this C will be classified here, not here, because this will calculate. Suppose if I have another pixel of unclassified, it will be considered over here. And this is how they put that this is scatter plot of two band, red band and infrared band. By applying parallel pipe, this is the parallel pipe sandy area, and different features they have kept over, and there is a little confusion of these two features, where it is coinciding here, where it is coinciding here, where it is coinciding here. But this fellow, you see that confusion rate, amount of confusion is very less. Only at some point it is having some confusion with respect to minimum distance. So this is a comparison of parallel pipe to classification, you see, and it's a little bit comparable, because this area, you see, major changes indicated by white circle. You see, this area is unclassified. Then it will be a problem for us. But in this case, minimum distance case, it is not like that. It takes everything and then classifies and give it to us. But it is almost looking correct also. Coming to the last one, it is maximum likelihood classifier. So classify pixel based on the probability. It will take the probability, what is the maximum possibilities of grouping the classes. If you know that the probabilities are not equal to the classes, you can specify weight factor. Sometimes we have to intervene the system to give the weight factor. For example, if you know that the large percentage of particular image area is forested, larger area of your study is forested, you may want to invite that class a higher probability than other class. If you assign the system will carefully match the pixel value, and then it will classify. Say for example, this is the maximum, it's a diagram, probability density function derived from multispectral training data. If your data which is having more distribution of forest, maybe you can group all the unclassified, maybe it will read the data, and this is very accurate. People are using mostly maximum likelihood. But this is having little problem with water and wetland, and probability of unknown pixel being one of the classes. If unknown pixel has brightness value within the wetland region, it will group into the wetland region. And this is the probability. You see, they made the circle. There are two circles of forested area. This is agriculture area, and because that too is the top, you see forest area and agriculture area. Other things are agriculture, so that is the dominant. But it will put the band 1 and band 2 information. Then you have your this one classification representation, and you see that the ellipse represents the standard deviation from the mean, and you see that this fellow is coming to near to forest. But by looking here, this fellow will be classified agriculture. It is not like that. So when you plot in the probability density, by taking probability density, you see that where this will come exactly it will match. It will not be considered as a agriculture. It is by taking the value of P of x into Wi or P of x into Wj. So minimum distance classifier takes the distance, but no minimum distance if you apply it, this will come to agriculture, but it's not agriculture. But it is most accurate, as I said, considers more variability, but because of wherever the quality comes, time will take. Relies heavily on normal distribution signatures always. So this is you see better than other two. This gives a lot of perfection of the classification. You see among these three, this one is the better for understanding. So with this, the discussion on supervised classification has come to an end. So in this lecture, we have seen what is supervised classification, what are all the advantage and disadvantage of supervised classification, what are all the different types of supervised classification, and after learning this, we have to do practically of taking one image. Do many times, don't stop one time, and if possible, you do first visual on the same area and then do the classification subsequently. Then you will realize it is touch and feel method. I have been educated like that by doing first visual. So with this, this lecture is come to an end. Thank you.